Good evening, Ajay sir.
Sir, very good evening.
We'll start the session in another 2 minutes. A few more
Sure,
participants yet to join.
Yes, sure.
Yes. Well, some of the participants are facing the issue of downloading the course material. Let me demonstrate you how to do that. I'm going to share my screen and I'm going to show you. Okay, if you visit indianresearchers.com, you come down to this particular website. Okay, on this website here, we have given the resources, SPSS FDP resources. If you click on this, open this SPSS, the link shared in the WhatsApp. And if you come down here, there is a pay 2 and 3 course material. Click on this option. Once it gets downloaded, so this is, it got downloaded. Okay, and after it gets downloaded, what you can do is you can open that particular file. Just a minute, I'm going to share a window again. Okay, here it is downloaded. Now I'm going to right click on this and extract to SPSS workshop, and it will ask for the password. You need to type and click on OK, and it gets extracted in a folder like this. And you have close to some 16 files, including one PDF file, which is a demonstration file for the today's workshop. We have today amongst us Dr. Ajay Jamnani sir, who is the resource person for today. Sir is having a versatile experience in the field of marketing and the operations, as well as in the statistics. Sir is also a AI tools researcher and facilitator, SPSS tools trainer, and he has successfully conducted many FDP programs for various institutions. I wholeheartedly welcome you for this program, sir.
Thank you so much. Govinda
Yes.
sir.
Over to you, sir.
Thank you so much once again. At the outset, I would really like to thank IndianResearchers.com for providing me such a wonderful platform to interact all the learned people who have gathered here and who have taken this keen interest to learn this much awaited software that is SPSS. Though old, but still it is never growing old, as every time we have a lot of data being collected, research is evolving, it's continuously having a lot of importance throughout all these years, and research is an endless process, and so is the software, and it has been able to update its own versions, meeting the requirements of various researchers across the globe. So thank you once again. I just want to confirm if I'm audible to all. If you can just type into your chat box, just say yes or no. That's it. Yes, I can see yes. Wonderful. All right. So without wasting much time and I'll just try to share my PowerPoint presentation. So you could just confirm me if you all are able to see the PowerPoint. Just give me a minute. Is the PowerPoint visible? Okay. Yes. All right. All right. So to begin with, since yesterday we have had a very wonderful session by Dr. PM Kulkarni, who gave us about the insights about what research is all about and different types of research, and what are the categories and different types of research that one needs to follow, and the kind of work that every individual keeps on doing it. And then yesterday even I was just there for a partially for some time, and I could see like many people were asking a lot of questions, like if I'm doing this study, so what is the type of research that it falls under. So it was really nice to have such a wonderful and insightful sessions, and even Q&A sessions that I saw yesterday. So yesterday's session was purely only about triggering about what research is, what are the categories of research, and where does on a canvas, like which type of research evolves, and various levels of research. So today, very specifically, we are just going to see like what SPSS is, as today's day is confined to understand the interface of SPSS, what SPSS is all about. How do we see that software? We could see like there are some students, uh, some of the participants here are facing some issues with respect to the SPSS software. I'm sure that you would be able to figure it out at your end, because there are many who are able to access it. Anyways, so today we will be just seeing like what SPSS, a brief introduction about SPSS, its interface, and some few statistical tools, or maybe descriptive statistics as it is defined under the scope of today's FDP's schedule. So we'll be just seeing about descriptive statistics and what is the importance of it, and how do we really carry out this descriptive research, followed out with more number of intense kind of testing tools. We'll be seeing it more in details tomorrow, but today we'll just try to have a get and hands-on as to how SPSS functions, how does an SPSS interface look at, and what are the key tabs that we need to focus on. Okay, so shall we begin with the SPSS this thing software? If I just want everyone to just put a message saying yes, and so that I can just get going. Yes, yes, yes. All right. Wonderful, wonderful. Okay. One question. So how are all the participants here with respect to SPSS? I would just want you all to rate, saying that no voice. That means I have no idea about it. So that is one. I have fair idea about it. That is number two. I am really good at it. Number three. So 1, 2, and 3. 1 is no voice. That is no idea. 2, okay, I have just used. I have heard. 3, okay, I'm really comfortable at SPSS. I have used in past. 1, 1, 1, 2, 1, 2, 1, 2, no idea, 1. So that is no idea means 1. Okay. Okay. Wonderful. 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 I'm really surprised and I couldn't see anybody 3. Okay. I'm sure somewhere or the other you all must have used SPSS sometime, but nevertheless, I think by the end of this 6 days workshop, you should be ready with some hands-on, and with the kind of data resources that we share. I'm sure that you will be able to practice more onto it and become at least you would reach at stage 2 or 3. Okay, by the end of this function, this FTP. I could see some respondents who are saying 3 as well. So I'm happy that some people do have used SPSS in their past for their research work and for many other assignments. All right. So let us start with this. I hope my presentation is visible now. Basics of SPSS software. Govindra sir, can you just confirm?
Yes, sir. Yes, sir. It is visible, sir.
Wonderful. Okay. So SPSS, as it stands, a statistical package for social science. It's a powerful data analysis software widely used in academia and industry. This presentation, okay, I'm going to present. This is going to be, will provide an overview about the SPSS software interface and its key important components, or the tabs that we are just going to use for our daily research and even for advanced research as well. So people, those who have used SPSS and those who have a very fair idea about it, I'm sure that you should be aware of these 4 important aspects. What does SPSS include? That is, first, it has an attribute or the function of managing the data. So SPSS offers robust data manipulation and making it easy for preparing data for analysis. So here, manipulation in the sense, like once you have data been put into the software, you can always edit, you can combine, you can transpose, you can select, you can join them, you can deselect, and you can do many other things. So you can edit a lot of data into it, and then maybe on the basis of your requirements, you can always look out for respective tools that are used in the SPSS software. Second, most important thing, that it is a statistical software, used for analyzing your data, which provides a range of statistical tests and techniques to gain insights from data. Now here, statistical tests, we mean that for a lot of our research work, we generally try to capture data like what is the average amount of expenditure that a person does when one shops, one goes for online shopping. If you would want to go for online shopping, so what is the average ticket size that a person would spend? So average is nothing but mean. So when we say that average, there are different types of averages. There is arithmetic mean, there is median, there is mode, harmonic mean, geometric mean. So these are all types of different categories or families of averages. But generally, whenever we say average, it is nothing but arithmetic mean. This is the most common synonymous word when we say that average is nothing but mean. So average, that is mean, is one statistical tool or a test that is. Likewise, there is something called as probability. Likewise, there is something called as correlation, regression. So these are all different types of statistical tests that one would want to perform on the data. Yes.
Sorry to interrupt. I think that PPT which you were showing,
Yes.
it has.
Yes, I'm aware. I just wanted to talk. So I've just switched on. So as I move to the next slide, again, I'll just go to this slide. So I'm just talking only on the second point.
Okay, sir.
On this slide. So this is the point that I was just talking about: statistical tests and techniques to gain insights from data. So this is what I was just focusing on: the statistical test. Then third point, that is reporting and visualization. So SPSS enables users to create professional looking reports, charts, graphs to communicate findings. Now, though SPSS provides reporting and findings, so again, I'm just switching the screen. So we are talking about the third point, that is visualization and reporting. SPSS has been able to adapt itself to provide as sophisticated visualization of our data. But still, somewhere I feel that in the market, there are still many other tools. When it comes to data visualization, there could be some other tools that can be used. But for analysis, for calculation, for formulas which are being embedded into the softwares, and the kind of results that you would want on the basis of hypothesis and p-value and many other statistical tools, SPSS is the best software that every researcher should have an experience, and they should be using it quite often. So data visualization, I think yesterday the resource person also mentioned something called as Power BI and Tableau. So these are some two external, another one more open database sources. Trial versions are available, open data sources also are available. You can always use them at hand. But nevertheless, SPSS also gives you a fair amount of data reporting and visualization. So I'm back to the PPT again. Fourth one, extensibility. That is, software can be customized and extended through add-ons and programs and languages like Python and R. So these are some new additions that have happened. So, but this will require only if at all you have had an much more a better hand on Python and R, other coding languages what are there in the market. But the meaning here to say is that SPSS has been able to quite easily dwell the new tools which are there into existence. So considering the scope of this 6 days workshop, I think we should be focusing only on this second aspect more widely, that is statistical tests, the statistical analysis part of it. Okay, so am I being clear upon this? Can I have some yes and no on this? Yes. Okay. Yes. All right. Perfect. Okay, I'm moving back to the slides again. So once you open the SPSS software, those who have been able to get the access of this the trial version of SPSS, there are three important things. Once we open the software, I'll just show you the version of it. I'll just try to navigate through the SPSS software. So there are three important things that one needs to look at once you open the software. There's something called as data view, second variable view, and the third one is toolbar and menus. Once you have had a good hands-on experience on these three aspects, I think you are really good to go ahead with any type of data that you are working on your research work, on research papers and many other things. So first one, data view. Any data that you collect, be it through any sources, be it through Google Doc, be it online, be it Typeform, be it SurveyMonkey, or be it any kind of different types of files that you are collecting data, or maybe even physical that you're just trying to, maybe if at all you have a physical questionnaire form in your hand, and then you go to the respondents, ask the questions, and then maybe you come back and you go on your spreadsheet, that is Excel. So you try to collect the data. That data, whatever you want the SPSS to do with, the SPSS you would want to perform the SPSS to work on the data that you have collected, that everything gets captured under one tab called as data view. Okay. Second one is called as variable view. Once you have the data being put up into the data view tab in an SPSS software, the variable view will automatically try to understand what you have fetched into the data view. I'll repeat once again. So once you have the data, you punch in or you just shift, either you control copy paste into the software, or there are different ways how you can import the data through Excel. Directly you can Excel, or directly you can paste the data into the SPSS software. Once you place your data into the data view tab, the variable view will automatically reflect and it will try to read and sense what is the data that you have put into the data view tab. So variable view will understand what is the type of data. Now, yesterday we had a discussion in the first day. So again, I'm switching to the screen mode. So yesterday we had a discussion that what are the different types of data. Once you have the data, based on what kind of test that you are going to perform. So understanding what data that you are collecting is very important. It's a thumb rule. So different types of data or categories, yesterday we have seen, that is types of measurements. There are 4 types: nominal, ordinal, interval, and ratio. Am I clear on this? Yesterday we have had a little bit of brief discussion about these 4 types of data that we had. Okay, perfect. Yes, I'm getting the responses on the chat box. Wonderful. So 4 types, that is nominal, ordinal, interval, and ratio. I again switch back to the PowerPoint slide. So variable view does a function of understanding what data that you have fetched in. Is the data belonging to a nominal? Automatically will just capture. Is the data ordinal? It will capture. And interval and ratio, by default, SPSS considers that as a scale. So whether it is interval or ratio, it falls under the scale type of a drop-down menu box comes into it. I'll show you today. I'll just show you a demo. How does the data look like? So data view, variable view, in which now you can edit, you can you have to label it. You can, the kind of output that you're going to generate. Most of the things, the visibility of your output depends like what have you done in the variable view. So I'll just show you a live demo once we are done with basics about understanding what SPSS software is all about. Third one is the toolbar and menu. So the data editor window provides a range of tools and menus for data manipulation, for data analysis, and output generation. Now this is something like a magical buttons that you need to you need to play around, you need to get hands-on on this different toolbars and menus which are there in the SPSS software. So once you have the data being captured correctly and the variable view, you just try to look at it like how you would want to have your output based on the data that you have had. So variable view, you can polish your data in the variable view section, and then comes the toolbar, the kind of tools that are available in the SPSS software which is embedded, and just with click of buttons you will be able to generate output of results. But there are some steps that one needs to go through it. So I have also shared one PDF document to all the participants along with the files, SPSS files. I hope it has been shared. I just want to confirm to Govindra sir.
Yes, sir, it has been shared with everyone.
Okay. Okay. Can the participants just confirm if at all you all have received the PDF copy, a worksheet kind of thing? Yes. Yes. Almost. Some have said no, but I think most of them they have said yes. I'm sure it should be there. Okay. Okay. I switch back to the slide mode again. All right. Now this is what we see in the variable view section. So there are variable names, data type, the type of data stored in the variable, whether it is a numeric data or whether it is string data. So numeric, if at all the data that is punched in terms of numbers, 1, 2, 3, 4, 5, 10, 20, 40, 50, whatever. Let us say like if at all you would want to ask, you in your questionnaire, let us say like you have asked the respondents, what is the type of OTT platform that is apart from television, the OTT platforms like Amazon Prime, like Netflix, okay, like Disney Hotstar and many others. So let us say like you have asked the respondents like which is the type of OTT platform that you have subscribed. and how many you have subscribed. So some would say like I have subscribed to only Netflix, that is only one. Some would say like I have subscribed to all the three. Some would say like I have subscribed to 12 OTT platforms that are available. Uh, so so all the data that has been captured, 1, 2, 4, 10, 12, that all data falls under this numeric. Then others, maybe another different types of questions, like whether you like a specific web series on a Netflix. So and you have liked. So you would give your responses in the question saying that did you like, I didn't like, I somewhat liked. So these are the three options. So these are like, didn't like, and somewhat. So these are the three sentences or the three words that you have used in your questionnaire. And if that has been captured, and once you put that into the software, that will take the data as part of string. So string is something which is alphabet, something which is denoted your data, which is captured only in terms of alphabets. So by default, once you punch that data in the variable view section, the SPSS will automatically identify, and it will give by default it is numeric or string. Only in very few cases, if sometimes you feel that no, this is the alphabets or alphanumeric that you have given the code, it should be considered only as a string, then you can select it. So you can edit it. By default, it will try to understand what you want to do with your data, or what is the type of data that you have fetched to SPSS. Third one is a measurement level, what I was just talking to you a while ago. That is, it specifies the level of measurement for the variables, whether it is nominal, ordinal, and under the scale you have interval and ratio, the four types of measurement scales. So variables that fall in. So these are by default, these are the three options which are available in the SPSS software. So if your data is nominal, it will automatically select nominal. If not, ordinal. If it is either interval or ratio, it will fall under the scale options. Fourth one, variable label. A descriptive name for the variable, providing context and meaning. So once you have given some information, some heading to a variable, and if you would, in your output, if you would want to have little bit more elaborative thing, like did you like this particular movie? So I am saying about this 6 words which is forming a sentence. So that sentence you can type under the variable label, because in the output, that is how you would want to have your sentence being projected along with the analysis, the data, the table, and the formats. So variable label will allow you to write the type of sentence that you would want, because the same sentence along with your output will be reflected, and the same thing you are going to use it in your research papers or your working papers and so on. So variable label. Variable name identifies for each variable whether it is a variable in the data set and so on. So we'll just see the actual SPSS software in some time. Then comes the output viewer. Once you have certain results, as you can see on the left, these are the different types of outputs that are generated in the SPSS. So you have results. You could have even pivot tables and annotations, but most of the statistics, the data that we work on generally comes only in the falls in the first section, results. The output viewer displays the results of statistical analysis, including your tables, charts, and other outputs. So we'll just see that. We'll take up one exercise today, one or few exercises based on the time available with us, and we'll just see like what is the output that we are getting, that we would be generating based on the data that we fetch into the SPSS software. Next one, there is something called as SPSS syntax editor. So we may not go into this detail unless you really want to have a very specific output. So there you can code your version of your output, the desired results, and accordingly you can edit. So there are certain limitations under this, but nevertheless, so syntax editor allows user to write and execute custom SPSS command syntax for advanced data analysis. So this will be covered in much more in an advanced kind of workshop SPSS software, wherein for example, there is something called as parametric and non-parametric test. So precondition is that whether the data is a normal data or not, that is, it follows a normality test. So these are some a little bit difficult jargons. I don't want everyone to burden with more amount of these difficult jargons. So let us be at the basic. Let us try to cover up what all we have in our hand. We'll try to perfect as per the schedule what we have, and we'll try to focus on that. Second one is automation, and third one is collaboration. So many other things. So this is purely meant for more advanced data analysis. Now, navigating the SPSS interface, you have this, as I just told you, this is a summary part of it. So data editor, then there is output viewer, syntax editor, as I just told you, this is for more complex and custom based SPSS output. And then you have the menus and toolbars, which provides a range of data management, analysis, and reporting features. So is this clear so far? I hope you are able to understand like what is SPSS. So can I ask you one very simple question? Okay, very simple. If you just know yes, if no, then that's all fine. One very simple question. So what are the two types of views that you see once you open the SPSS software? Two views. What are the two views? Very good, very good, very good. Yes, yes. Data view and variable view. Wonderful, wonderful. Okay, 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 okay. All right, all right. I think we'll take the Q&A sessions maybe in a while. I can see some respondents raised your hand. Let me cover another little bit, maybe another 10-15 minutes, and then once we have the actual data sets and we start with the SPSS software. Before that, maybe I can just take a Q&A session. Okay. All right. So conclusion and key takeaways from this part. So that is, it is a comprehensive data management, statistical use for advanced statistical and analysis, flexible reporting and visualization, and customizable and extensible kind of interface that we can see in this. So the second part, that is introduction to descriptive statistics. Okay, I'll do one thing. Maybe we can just take some questions. Govinda sir, if you could just give an access to Sri Gita.
Yes, sir.
We'll have only a couple of questions because we still have a lot to cover. Maybe questions and answers will continue for a long time. So let us, yeah. Sri Gita, you can just go ahead.
Just a minute, sir. I'm just
Sure.
changing the settings so that you can talk.
Okay.
Yeah, Shri Gita, go ahead. You can turn on your mic and camera and you can ask the question.
Yes, sir. Thank you for giving us this opportunity, sir. So, how to write the review of literature with the help of SPSS software, sir?
Okay.
Sorry to interrupt. Well, for SPSS software will help you to do the statistical analysis. For literature review, at the end, last day, I'm going to cover something using this certain set of softwares, AI tools and other things.
But few people are using this, or maybe I have this query, so that's why I'm asking, sir.
Yeah.
If it is possible or whether it is not possible, sir.
So can I take? Can I take?
Yeah.
Yeah, Sri Gita, see, SPSS is purely a statistical software. I doubt, I'm sure that it doesn't do any sort of literature review. So SPSS is purely a statistical analysis software. So once you have the data, it will try to perform the kind of tests that you would want to perform based on your objectives and research questions and objectives. So literature review is not possible through SPSS. As Govindraj Mane said, that is on Saturday, the last day. So we'll be covering few literature based AI tools through which you would be able to capture a literature review and perform some sort of literatures based on the softwares that have been shared. But SPSS, no, literature review cannot be performed on SPSS.
Okay, sir. Thank you a lot.
All right. Okay, then I'll just move on to the slides now. So the second part, that is introduction to descriptive statistics. As the word says, descriptive. So descriptive statistics is foundational branch of statistics that focuses on summarizing and describing the key characteristics of a data set. So this presentation will explore on importance of descriptive statistics and how to leverage SPSS software to uncover insights from your data. So once we are done with this PowerPoint presentation, we directly switch on to the hands-on exercise on SPSS. So let us run through this. So descriptive statistics, generally once we have the data, the first thing that comes to the researcher's mind is like, what should I do with this data now? Okay, there is always a curiosity that I should directly jump to the statistics. I should directly jump to a specific test. I should perform a t-test or a chi-square test or a ANOVA or correlation regression. But before that, one needs to understand, what is my data talking all about? How is my data behaving? So there are two important concepts here. I switch on to the, again, the main meet mode. So there are two important things here. The data that you capture, we call it as something called as central tendency. That is, the data that have you captured, how is it behaving with respect to an average? So average, as I just told you, that there are 5 types: mean, median, mode, harmonic mean, geometric mean. But harmonic mean, geometric mean, it is used only for special purposes. In SPSS software, and even most widely extensively used are the 3 types: mean, median, and mode. Out of all the 3, again, mean or arithmetic mean, what we call it as, is most widely used. So when we talk about average, we'll just talk about these 3 things, that is mean, median, and mode. So those who do not have this statistical background about mean, median, and mode, it is not that big thing. It is not a big rocket science. You can always browse. You can Google it out. You can go to ChatGPT. You can use other AI tools just to find out basics about what these 3 tools are. Average, that is arithmetic mean. You have a set of data. It pools the entire data, and one central value, it will give you a representative. So that one value is a representative of all your data. It gives us the central value. So any data that you are collecting, let us say like you go to a retail store, and let us say like you are the owner of a retail store, and you would want to know what is the average shoe size of people, those who come, those who walk into your retail store, and accordingly you would want to place your order to your respective suppliers. So what is that most moving item of size of a shoe number that people come and they buy? So depending on the foot size, okay, the people would buy. So generally we know that for men, let us talk about men. So average maybe something around 8 in Indian context I'm talking about. So size number 8 and 9 are most quite and widely used. Size number 10 or 11, the people those who have got very big feet, they would buy. People those who have very small feet, maybe number 7 or 6 would generally be preferred. But most of the students, most of the respondents would generally take for 8 and 9. So once you start collecting the data based on the number of people, those who have bought certain products, you go back to the database, capture all the data of all those men who have bought a specific brand of shoe, and you try to jot down into an Excel sheet that customer 1, he bought a shoe size 9. Customer 2, he bought a shoes 8. So third one 8, fourth one 7, seventh one 6, 7, 8, 9. So they have bought 8 size, 9 size, 9 size, 9, 8, 8, 8, 7, 6, 7, 6, 7, 9, 8, and so on. So you have captured a database about all this. Now you would want to know on an average, like what is that average, what is that shoe size? So you may get some figure, let us say like 7.75. So which is next nearly rounded off to 8. So you feel that, so now you have a fair idea that shoe size number 7 and 8 are most preferred because the average value that you have got is 7.75. Maybe there could be some errors. So those are called as outliers. So I'll talk about outliers maybe later on if at all there is some query on that. So to know the average, that is arithmetic mean, is one tool. So what is the data that you have and what is that average value that you are getting out of the data is also very important. Second, that average value is how much differing from the actual value. So when we say that 7.75 is the average shoe size, let us say like you have captured the data of 100 customers in last month, being the festive season. So many people had footfall in a specific retail store. They bought shoes and the average shoe size that you got is 7.75. So this 7.75 is how far from the first customer. First customer, he bought a 9 number shoes. So how far it is? 7.75 and 9, there's a difference of 1.25. Second customer, he bought 8. 7.75 and 8, difference is 0.25. Let us say like third one, he bought a 7 size and then so on. So how far is the variation? across this average. So average is 7.75. And how far is this variation that we see? So above 7.75, that is 9, 1.25 difference. Above 7.75, 8, that is 0.25 difference. Let us select there was one customer who got 6. So there's a difference of 7.75 and 6. Its difference is 1.75. So there is a variation. There is a variation across this mean. That is arithmetic mean. So how far is the variation? Is the variation too big? Is the variation too close towards the average? That also is a very important aspect once you are doing your research, because higher the variation, maybe the insights, the data that you get may differ on a large sample size. Maybe you need to capture more number of sample size to have very close variation. So generally there is a thumb rule. We say that smaller the variation, better is the results, or uniform, or consistent, or homogeneous. These are the different nomenclatures that we use. So anyways, I'll not go much much more depth into it. I'll go back to the slides. So when we are talking about descriptive statistics, we are talking about these two elements here. Can you see this? Central tendency, that is averages, and variations, that is variation. If we call it in terms of standard deviation, or variation, or range, or mean deviation, and variance, and many other terminals that are used in this. So first, under this, understanding your data. And then there is distribution. There is something called as skewness and kurtosis. How well is your data distributed? In one of the chat boxes I just overread, somebody asked, like, how do you know whether the data is normal or not? So there are some tools, okay, again available in the SPSS, through which you can find out whether your data is normal. Normality tests are there. There is KS, okay, Colmoro test is there. Shapiro's Wilkinson test is there. Then there is box test is there. So there are then outliers you can just find out from the data. So there are various tools that are available, various things through which you need to go through it. Second one, identifying trends. So descriptive analysis reveals some patterns. What is the average, okay, shoe size that a person buys? What is the average expenditure? What is the average savings that one would do? And many other things. Then patterns, outliers, relationship within the data, and many other things. Third one is communicating your findings. So descriptive statistics also gives a point on this. So summarized statistics and visualization provides a concise way to communicate data insights to different stakeholders. So for example, mode. So at the time of pandemic, that is COVID, so we had a data vision. Again, I'm going to the meet mode. So here, so during a pandemic, that is COVID-19, there was this Arogya Setu app that was deployed by the government, and in which we could see that there was a map. So we could see that the Indian map, and we could see there are different hotspots. That is, in the Indian map, we could see like which areas or regions or states had got different color shadings. So from yellow to red. So yellow means, okay, there are some number of cases. Okay, moving towards a little bit orange. So more number of cases. You need to be more, okay, aware of it, and you need to be more careful. And red indicated that, okay, the severity or the number of cases in a specific case or in a state was very high. So you need to be more aware of this. So this is what we are talking about. So visualization provides a concise way. Now this also talks about, that is on an average, that more red means that means number of cases. So mode is another one more type of average which tells us the highest number of cases in which specific city, in which specific state. So the higher the number, the color shading would go towards red. Okay, so it starts from yellow, then it goes towards slightly fade orange, dark orange, and then red. So based on the number of cases, so mode tells us the highest number of cases or the most intense number of cases in which, okay, a particular state belongs to. So descriptive statistics, it tells us some insights about what your data is all about. That is understanding the data, identify the trends, and communicating your respective findings. So assessing and importing data into SPSS, we'll just see this today. Though I have provided you all a free ready-made SPSS files, so that you all don't spend much time again on punching the data and putting that into SPSS. Okay, but still, I'll just show you one small demo based on the same data. I'll just try to edit and manipulate, and I'll show you the files. So identify the data source. So data sources can come through various places. That is through, it could be a spreadsheet, that is your Excel, different databases or text files. Okay, CSV file through Google Doc, most of the widely used these days. Okay, Google Doc forms, as well as type form is another one more, or survey monkeys and so on. So whichever type of data extension files or sources that you collect data, SPSS is very a robust kind of software which blends easily through the different types of data sources that you have. Okay, but generally I would prefer that if you can have it into a Excel or an CSV file, that should go very easily without any hassles and so on. Second one, import into the SPSS. So use SPSS intuitive data import tools to seamlessly bring your data into the software. And third one is prepare your data. So you need to clean, transform, and format your data. It can be done at SPSS, but sometimes there are a lot of errors that you would encounter if at all you do not clean the data. Preferably, you can go to an Excel. You can just check out how do you validate your data, data validation, and data compiling, and you could just clean your data. So you're cleaning your data in the sense like there could be some missing values. So in the SPSS software, I'll just show you how if we just miss some data accidentally, and then we directly go to the SPSS and we click onto the different tools, and then you have an output view in which the output you will find that there is something called as missing values. So SPSS detects that, it will try. But as a researcher, you need to be very well and cautious enough that this is the output that I've got in the table. There is something called as missing value. So which is that value that I have missed? So again, you need to go back to the data view or go back to the Excel or the spreadsheet where you have collected the data, trigger it out, and you can add or you can delete or you can little bit try to edit that data and get the actual data being filled, and again you can run that. Sometimes the data also has some outliers. Okay, now outliers are something which doesn't fit well into your data. Okay, because as someone just message saying that normality. Okay, that is normally the data. So your data being not normal could be one of the reasons, because the data has got some outliers. So outliers are those data which are not fitting with your data in most cases. For example, I'll take back to the same case, that is of shoe size, just to understand, just a simple example. So let us say like there was a person who is very tall enough and he's got a very big feet, and maybe even the biggest size, that is 11 number size, is also not available beyond 11. Let us say like his size is 12 or 13, but that shoe size is not available in most of the retail stores. Now capturing data from that respondent, using that in your research work, will cause some problems, because that 13 will affect your average size of 7.75. Your 100 respondents, you had 7.75, and 101 respondent, the 101st respondent who has come, he has got the average size of 13. Now if you put that 13 into your data, your 7.75 will casually shift towards a bigger value. From 7.75, it may jump to 8.1. Now that 8.1 is happening only because of that one data which is having 13 size. Okay, are you trying to are you getting this? So those data are called as outliers, which are extremely high or which are extremely low. Let us assume that there was a short guy who comes and maybe his feet size is very small and he would want to have a size of 4 size of a shoe. But generally men, they have a little bit bigger feet. Maybe it starts from 7 or maybe 8, 9 and 10. These are the three sizes of, if I want, I can just ask a question, and I'm sure that many of the respondents, all the men here, will put their shoe size here right now. You will find that a lot of responses will come as 7, 8, and 9. For women, it is slightly a little bit lesser, maybe one number less. It will come to 5, 6, and 7, something like that, and so on. So outliers are those data which are on the extreme ends of a normal distribution chart. So normal distribution is a bell-shaped curve which falls under the extreme values. So when we put the data, you get the normal distribution curve. Anyways, we'll discuss that if at all time permits. Let us focus back onto this. So here I was talking about, okay, that is cleaning your data. So you have your missing values and the outliers. So you need to eliminate or you need to remove that particular data set from your data collection so that your analysis can perform well based on the normally distributed data. Third one, that is SPSS software gives you these different types of analysis has to be done, exploring univariate descriptive statistics. So today we'll be focusing on these tools here. Frequency distribution. So whatever values that you have put, what is the frequency count, what is the percentage, what is the cumulative frequency values, percentage, and so on. Second one, central tendency, calculation of mean, median, mode. Dispersion, calculation of range, variance, standard deviation, and so on. And the fourth one, normality. That is whether the data is normal. Just for an example, if you can see here the slide which is there on the right hand side. Okay, so it follows a bell-shaped curve. Okay, normally it is not a perfect bell-shaped curve, but you could see the data values. It goes up, up, and then generally comes down in a bell-shaped curve. So if at all on freehand, if at all I have to draw this, I'll get a line something like this, which is falling off a bell-shaped curve. So this tells us, this is also a significant aspect which tells us that your data is normal. But one shouldn't conclude only on basis on this histogram. So this is a histogram. So you cannot conclude only on the histogram whether your data is normal. There are many other things. You need to check the outliers. You need to check the box plot. You need to check the KS test, Shapiro's-Wilkinson test, and many other things. Okay, to confirm whether your data is normal. Likewise, there are even p-values which also tells us statistically whether your data is normal or not. Anyways, so this is a separate off the track, okay, thought aspect, but we'll just see whatever possible. I'll just try to share my knowledge with all the respondents here. So this is what we would be doing. Calculate the measures of central tendency, mean, median, and mode. I'll just move ahead. Likewise, dispersion, we talk about range, we talk about variance, and we talk about standard deviation. Out of all the three, standard deviation is more a stronger variation or a stronger attribute when you talk about dispersion. So this is one value which is widely been checked for once you have a data. Okay, standard deviation, variance, though the difference only between this is that is the square root of this, and the variance is standard deviation square, and standard deviation is root of variance, and so on. Range just tells us about the smallest and the largest value. So generally, if at all you all have seen this Shark Tank, I hope you all have heard about this Shark Tank. Just let me see if at all there are some answers. The Shark Tank serials, if at all you all have used, you all have seen, yes. Okay, so again, it's a platform wherein people who are in need of funds to build up their business for expansion, for mentoring, and for many other. Okay, so there are sharks. There are people who are from different business backgrounds who are with hefty cash amount and all that, and if they feel that there is some business idea that you are pitching, and if at all I would want to spend and I would want to invest into it. So as a shark, I would invest, and I would want to be a part of your journey. So if at all you all have keenly observed, even the Shark Tank also, they use this terms in terms of descriptive statistics. So they ask the pitchers, the people, those who come to pitch their idea, the business. So the sharks, they would generally ask, what is the product pricing that you have used for your portfolio? So maybe a person is having n number of products in his business, they would want to pitch, and then the Shark Tanks ask, what is the smallest price and what is the largest price, because you have got many products in your businesses. So what is the range? And then the pitcher would say, like, we have got range of products which starts from 99 and it goes up to 999. So when you say that 99 and 999, you are talking about range here. The very first one, range, that is the smallest value, minimum value, so the lowest value and the highest value. Lowest value and the highest value. Then they would ask again, what is the average sales that you have in your business? What is the average profit that you have? Then they would say, like, in some cities we have low ticket size or low sales. In some cities we have very high, but on an average. So average is nothing but again measures of central tendency. So in a way, they are also asking your average price, range, then what is the variation and so on. So these are different things. All right, so calculating measures of dispersion. Now these are things that we would be seeing today. Histograms, or maybe these are the different types of charts that are visible in terms of visualizing. Scatter plots, this is something with respect to your correlation. We'll just see this. Bar charts may not be, maybe this visualizations are not this advanced, but as I just told you, like Power BI and Tableau can be more enhanced, be being used, okay, when it comes to visualization. But bar charts, as you can just see, this is the bar chart here. This is most very widely feature that has been used in SPSS. Okay. So lastly, that is interpreting descriptive statistics. How do we interpret the results of this central tendency? Understand the typical central value. So how is the data being, okay, available at the center, okay, with respect to all the data that you have? Dispersion, the spread and the variation of your data, which is at the center, that is your average, and how well is your each and every value, okay, differing from the average. Distribution, we talk about the different types of shape, that is kurtosis and skewness and normality, this type of distribution, that is frequency distribution shape of it. And relationship, if at all there is some association between the variables. So we'll see, like, I mean, association, when we talk about correlation. So I think correlation will cover up tomorrow, and even chi-square we shall cover tomorrow as it is scheduled. Okay. So by interpreting these descriptive statistics, you can gain valuable insights into the nature of your data, setting the stage for more statistical analysis and informed decision making. Okay. Now comes a point that you all must have heard something called as descriptive and inferential. So descriptive, whatever data that you have, we say that you are just simply going to organize that data into a specific order. Okay, maybe ascending order, descending order, or the kind of, okay, distribution that you have, the shape, whether there is a hump, whether there is a flattenedness, and many other things. You summarize the data. That is, you tell us like what is the average, mean, median, mode, standard deviation, and so on. Summarize. Okay. You simplify the data based on the data that is there, and you just present the data in the form of different charts that are available: histogram, pie charts, and many other. On the other hand side, apart from descriptive, there is something totally opposite, that is inferential statistics. So inferential statistics generalize from samples to population. Hypothesis testing is a key integral part of inferential statistics. So descriptive data statistics, we do not perform any kind of statistical tools or tests. It is just very simple. You organize the data, you summarize it, you simplify, and you just simply present it. So this is one essential key part of your data analysis. But more important is your inferential statistics, which we'll be seeing from tomorrow onwards, and followed by the other resource person, Dr. Rohit Mudgekar, and so on. So tomorrow also we'll be seeing some part of inferential statistics with respect to chi-square testing and one sample t-test and some. So that will be going to this. So just a little bit brief information about what inferential statistic is. We have a population. We draw a samples. From the sample, whatever calculation that we make, that calculation in terms of statistics, we call it as a sample statistic, and we estimate whatever values that we get, we consider that to be as close towards a population parameter. So any type of statistical tools, the data that we do for a sample is called as sample statistics. Against that, for population is called as population parameter. Nothing to worry if at all you are not understanding this specific slide. It's all okay. It is just a brief introduction to tell us like what is a population and a sample. So any analysis, any inferences that we make, that we would want to conclude in our output on the basis of sample, if that fits in well for your population, then we say that it is statistically significant, or else it is not statistically significant, and so on. Okay. I'll not describe. I'll not go much more details into it. I'm sure that many are eager for the actual hands-on for this SPSS software. So parametric and non-parametric, broadly, if I just say like about the population, about the data available, I'm just going back to the meat now. So if your data is normal and if the population is known, we call it as a, okay, that is population. That is, here we can see about population is completely known, we go for parametric test. Otherwise we go for non-parametric test. In another sense, the important aspect here, if normality assumptions is required for parametric test, if your data is not normal, generally it is preferred that you go and collect more amount of data. Okay, maybe the sample size is not enough, not adequate enough for your data to perform certain inferential statistics. Even after doing this all exercises, you have had an enough number of sample sizes, which is again standardized number of sample sizes being identified by different statisticians. There are standards like, okay, Nunali has defined a specific, that is 15 number of times the type of variables that are available. If you calculate 15 into the number of variables that you have used in your research, sample size, if that much is enough, you can statistically can say and you can justify. Then there is Cochran's sample size calculation, which is standard thumb rule, that is 384 for infinite population. So there are different sample sizes being defined by different statisticians and researchers. But nevertheless, if your data is normal, we go for parameter tests. And in spite of all the additions and sample sizes being calculated, if still your data is not normal, then you need to go for normality assumption, which is not required. Then you go for non-parametric test. So I'll just share some of its details. Okay, so let us see. So this is the type of test. If you want, I can just take a screenshot of this. So parametric procedure or parametric test and non-parametric test. So if at all you are trying to compare between two means, yesterday there were some queries, but maybe I hope this slide should give you some brief idea, maybe just a bird's eye view as to what type of tests can be performed under parametric and under non-parametric. The same type of test, two sample tests, if your data is not normal, that is the assumptions what we just saw this, okay, this slide. If any of this data is assumptions is not falling under parametric, then you can perform the similar type of test for two sample t tests. Mann-Whitney test can be performed. I just want to disclaim, I just want to put a word of caution that these all different types of tests are not a part completely, the non-parameter tests are not a part of this workshop. But let us see, like wherever time possible, we'll try to share some knowledge on this or try to share some resources available on this. So if at all you are performing a paired t-test, the opposite non-parametric procedure would be Wilcoxon's signed rank test. For ANOVA, Kruskal-Wallis test. For Pearson's correlation, you can use Spearman's rank correlation in terms of non-parametric tests. Okay, this is the last slide for today. So hypothesis testing follows under these two types, parametric test and non-parametric test. Under parametric, that is if your data is metric, so that is t-test and z-test, one sample. Two sample, you follow, that is two groups, that is equality of means for t-test, z-test, or else you can go for paired t-test. If your data is not parametric, then you go for non-parametric. So you have again one sample, two sample, you have chi-square, which we'll be seeing tomorrow. Okay, then there is case test, runs test, binomial. Under two samples, you have chi-square, which will be seeing again independent samples. Okay, then Mann-Whitney, median, case. Here again we have sign test, Wilcoxon, Neymar, and chi-square test. So scope of this research, this workshop has been clearly communicated that it's merely impossible to cover all the types of tests, but whatever the most type of basic tests that are widely used by a lot of researchers falls under this particular slide. Okay, so with this, I just end my presentation here, the PowerPoint presentation. I'll just quickly run through you on one more presentation before I go to the SPSS interface, which talks about which I have given a lot of screenshots under this. Okay, so at this point, if at all there are any queries, I would just want to take up. Govindra sir, you could just allow the respondents to unmute themselves, and if at all there is something, only a few questions, maybe another 4 or 5 minutes, we can just take up because still there is a lot to be covered. I would just want to go on the hands-on experience before I move to the next PowerPoint.
Yeah, I request participants to go ahead with the questions.
Good evening, sir.
Yeah.
Sir, what would be the counterpart of two-way ANOVA in a non-parametric test?
Specifically, yeah,
or a test which requires more variables beyond two, because in parametric the two-way ANOVA deals with more than two factors. What would be the exact choice for a non-parametric basis? Actually, we are doing a research on plant extracts, sir. There the sample size is being low, so we are dealing with the problem in choosing a perfect test, either be a parametric or non-parametric,
okay,
because actually the sample size is being low.
got it.
So kindly
See,
suggest me, sir.
I think we would be deviating from this objective of this FDP. Though I just told you, like, I mean, we are confined to this. And anyways, ANOVA and going further, I think the next resource person is already lined up. Rather than having the same repeated version of it, and so the same query you can post it into for our next researcher, the next resource person day after tomorrow, would be covering more in detail on that part specifically.
Okay.
Okay.
Okay, sir. It was a diagram. That's why I.
Yes, yes. Yeah, I understand. That's what I just told you. Like, I mean, I was very clear that based on this objective scope of this, we'll be covering only few things what is defined under this. Yes.
Okay, sir. Thank you. Thank you, sir. Thank you.
Okay. Maybe I can just read the chat box and I can just answer there itself. Yeah. Somebody wants to talk. Go ahead and then I'll just go to the chat box.
Sir, good evening, sir.
Yeah.
Sir, would you once again just brief the inferential statistics?
Inferential statistics.
Yeah, could you just brief it? That's
Okay. See, as I just told you, there are two types: descriptive and inferential. Okay. Inferential statistics is something, as the word says, like infer. So you have a population, and generally most of the studies are done on the basis of a sample. Okay, because population reaching out to the entire population of a research work is close to impossible unless you are doing a very specific study and you know that the entire population is available there. So if you're doing entire population, then there is absolutely no need of doing any type of hypothesis testing. You need not test your hypothesis. Hypothesis testing is done only under the category of inferential statistics. And inferential statistics, the base thumb rule says that you are drawing a small sample out of your entire population, on which that small sample you are working. You would want to perform some data. You would want to perform some data analysis, hypothesis testing tools, and you would want to generate some results only on the basis of samples, and which is representative of your entire population. So sample, on the basis of samples, you run certain tests, and whatever results that you draw, if that is that result representative of your entire population, running the test, the p test, the p value and other things, it will tell us whether it is statistically significant or not. Again, I think in the chat box I saw like would you be running some reliability and other validity tests. So these are some basic tests based on the, because you directly cannot take the sample and run the test and give your inferences. You need to check normality first. You need to check the assumptions for your sample, which is going to be representative of your population. Yesterday also, I think the resource person said like two important tools, that is reliability and validity, has to be checked. If at all you are performing certain tests, if at all you would want to run a factor analysis test or maybe some other test wherein that reliability and validity has to be tested. So all these tests have to be checked, and then you, if you pass on through all these different tests, the preconditions what are given under reliability, validity, normality, and then you perform certain statistical tests like t-test or chi-square test or ANOVA or multiple regression tools or something like that. Then only the tools or the analysis which tells us that you have performed, and then it can be a representative of your population. So inferential statistics, in short, we say that you are trying to infer the results of your population on the basis of small sample, but provided it passes on through all the different preconditions or the assumptions of the different types of tests. This is what I could explain.
Thank you, sir. Thank you.
Yeah, good evening, sir. Sunita here.
Okay, just sorry to interrupt. Sunita, we'll take up this as a last question from your end. I'll just go to the chat box after this, and we'll move ahead with the next part. So, Sunita, this is the last question. Respondents, please note this. Yeah.
Okay. Okay.
Go ahead.
Yes, sir. Sir, one thing before some time you tell about the outlier. Okay. Suppose the sample size is 130, and among this, that the 30 sample is showing the outlier. So, what should we do, sir? We should follow the non-parametric, or we have to follow that or remove that outlier.
Okay. Now, there are two ways looking at it. First one, if you feel that you have got sufficient amount of data from 130, you say that 30 is outliers, I will just delete everything, and you would want to take only 100. Now, taking that 100, if you can just take up, if you feel that this is enough, according to me, as you're saying, like 100 is still not enough, because as a minimum number of sample size that are required as per Cochran's formula for infinite population, it is 384, or based on Lunali, which again defines saying that 15 times the number of variables that you have used. let us say like the variables that you have used in your questionnaire are something around 25. So 20 or maybe 20 into 15 is already 300. So whether it's 384 as per Cochran or by normally 300, your 100 samples is nowhere close to it. So first thing is like you have to capture as much amount of data as possible. You need to increase the amount of sample size, increase it to around 400 or 500. And then from there, if you are able to draw that outliers, and if you come somewhere close to this standard number of sample size, well and good. Second thing is remove that outliers, 100 data sets what you have. You need to run that normality test. You need to check the reliability and validity test. If you are able to get normality, if you are able to get reliability, if you are able to get the validity test being done with this 100 sample test, you can still go ahead with your inferences and you can justify. You can always mention the note saying that the test has passed on all the things. Okay, and you can go ahead with the publishing and you can go ahead with your research work. But still, in a long term, based on the experience that even I have had, a lot of research work, a lot of research committee members, they would always question this unless you have a very strong reason to justify and to back up saying that no 100 sample is a perfect sample, because there are 30 who are outliers and I have used this and I have performed various tests. It has passed on all the assumptions and many other things. You need to strongly justify and try to convince a research committee member. This is what I could say. But still, 100 is a very small sample size for research work to be justifiable for a PhD work or for any research article to get qualified for top research articles journals under ABDC or Q1, Q2, Q3, Q4 set of journals and so on. Okay. All right.
Yes, sir, we can go ahead.
Okay. I could just see some of the questions here, which says, okay, not able to a resource question. Okay, go ahead. Normally test. So when normally test fails, we go for non-parametric tests. Yes, preferably, because if you really want to go ahead with non-parametric tests, or else you need to increase the number of sample size and again recheck to check the normal test. Yes, so normal test fails, we go for non-parametric tests, definitely, because only if the data is normal, then you go for that last slide which I just showed you. So go for parametric, or else you go for non-parametric. So can we get your PowerPoint? Yes, I'll just share it. I'll just share this PowerPoint with the organizer, Indian researcher, as well as Govindraj Mani sir. At the end of the FDP, that is once we are done with 6 days, I'll just share all the other PowerPoints available at my end. And requesting kindly share the PPT. Okay, why non-parametric common in Indian research? I don't know why it is common. Maybe you can perform. I think parametric research is common rather than saying non-parametric is quite common. Okay, depends on the type of research. Now these days a lot of mixed research is also been followed. More than quantitative, qualitative research have also evolved. Okay, so researchers are looking out for that type of data. So it depends on the area of study that you would want to work with. Okay, so can we do qualitative analysis with the help of SPSS like thematic analysis? I doubt SPSS supports any type of qualitative analysis. Uh, it is purely a quantitative. Okay, 99% all of your quantitative data goes under SPSS. Yesterday, I think Govindraj Mani sir also mentioned about qualitative, that is NVivo is one software. There are other some of the AI tools also is available, that is atlas.ai. That also you can just try for qualitative. You can just check, and then there are many other. But through SPSS, I would say that the answer is no. To perform qualitative, SPSS should not be used. It doesn't make. Is it necessary to remove outliers? Yes, definitely, because that is something which will create a hindrances at the end. Maybe if at all you are doing some sort of analysis, regression, or maybe trying to create a model, because see, models are generally, okay, outliers is a precondition. It's a mandatory condition that you need to check outliers, because model is something that is going to be utilized by industry, by corporates, by many other people. And if your model has outliers, and if you are still trying to propose your model saying that it is fit and fine, that means you are misguiding many other people. So removing outliers is again a precondition. It is always a good practice. So how do you deal with open-ended questionnaires with data entry in SPSS? A little bit difficult because open-ended questions, again, open-ended questions means these are qualitative in nature. So again, qualitative data, okay, very difficult in SPSS. SPSS purely, it's perfect for quantitative data. I have to do prescription survey from different OPDs, how to do the sampling. Maybe this is, we can have a little bit more discussion on this. I need to understand what is the data, what type of, okay. So fine, then I'll just go ahead. I'll just go ahead with my next part of my presentation. Can somebody confirm if you can just see this slide, introduction to SPSS?
Yes, sir, it is visible.
Okay. So quickly, I'll just run. I'll just take not more than 5 minutes, and then we'll switch on to the exercise itself. So in this this PowerPoint also, I'll just share it with the organization. They would share it to you by the end of this FTP program. So I'll not spend much time because we have already done this. So this is the outview. This is the first page that you see once we open the software. Once you double click onto the software link, so it says like open an existing data source, the very first one, or the second one, open another type of file which you have already been used. So recently been used. You can see on this window. This is what we see. Now, this is one very important slide. What we can see once you open your SPSS software, these are the different tools, the menu commands, what you were talking about. This is the toolbar icons. I think it is slightly blurred and maybe it is black and white, but I think we'll be able to make it up once we open the actual SPSS software. Okay, all this titles, what we can see here, this is called as a variables. Then case numbers on the x-axis. I'll do one thing. I'll just try to open. I'll just try to open the SPSS software itself. Let us try to open the SPSS. I request even the participants also to open the SPSS software has been installed. Those who have it, those who are able to access it. So I'll just try to navigate between these two slides as well as the SPSS software. So once you click on the SPSS software, the version is visible. I have a version of 25. Any version is fine as long as you are doing a basic statistics, unless you are doing a very high end or very sophisticated, more advanced data analysis. Any version is fine, up to 30, 32, and so on. So this is what we see, the SPSS software, and here we see that recent files. So recent file, these are some of the exercise softwares. Sample size, and these are some of the sample files also. If at all it is visible, this is a predefined under your database. Maybe some SPSS softwares will have this, some may not. Okay, some may have more than this what I have. So if what I have is SPSS 25 version, so this is some of the basic things that we would see. And I'll just close this. I'll just show you on this. So these are the two things. I hope it's visible to everyone what I'm showing here right now.
Yes, sir. Yes.
Yes. All right. I can see on the chat box. All right. So this is a SPSS interface. We see that there is data view, variable view. Okay, data view. So here these are the variables. This is VAR. You could just see by default it is there VAR on the top, and here we have all in by default. These are numeric. So I'll go back to the slide which talks about this. So here this all what we have on the top is variable, and this is called as a variables. And here this is called as a subject or the case numbers. All this empty thing, these are the empty data cells. What we have, this is your empty data cells. These are all your empty data cells. Then you have the scroll bars on the right and the left. Based on the data that you have, by default, it has this many data files what we have. Okay, so these are the scroll. Then data view and variable view. As I was telling that these are the two important tabs, view buttons what are there in the SPSS, data view and variable view. Okay, so I'll just go to the next one. Now SPSS main menu. So this is an old version. Okay, topic which talks about, which says there are 12 menu. I have 11 menu items based on the versions that you have, but doesn't matter. Out of all this, so you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have got 12 menu items here on the SPSS software, and accordingly, even you all should be having it. Now, out of all this 12 menu, 90% of the data, 90% of the times, the researcher would generally go to this analyze button, the analyze. This is where the really most of the statistical analysis or tools, the magic button, what you can call it for a researcher, analysis. If I just click on analysis, there are a host of other sub key buttons we could see. So analyze is one which is really important. Then transform and data and other these things depends on what data that you have. But mostly 90% you would find that researchers would generally use only this button. Okay, analyze. So data view, variable view, and out of all the menu buttons is the analyze button. Okay, all right. So data view window, this is how it would see. We'll take up one sample data. Okay, I'll just run through the slides. Variable view. So here you have all the variables. Okay, now under variable view you have this name. Okay, name. So here you need to be very specific, that is spaces are not allowed under name. Okay, and some of the preconditions that are there. I think if at all you all have that PDF open with you all, the PDF which has been shared, clearly it mentions about all these things. Okay, it will be a repetitive thing, but anyways, let us keep that PDF also open. Keep SPSS software open, and also please keep one of the SPSS files, that is exercise 1. Okay, we'll just see with that exercise 1 now. Okay, so this is variable view. Okay, these are all the description about under the type. So you have numeric. Okay, you can select numeric, and you have the size by default as width of the numeric value. Okay, as 8 and decimal as 2. 8 is like the 8 numeric value, that is in 1 lakh we have 5 zeros and number 1. So this is the width is 6. So likewise, the kind of data that you have, okay, if you have the width size more than 8, you can always go to this numeric, click on this numeric on this, and you can see this width which we have, that is 8. You can directly select this as, you can convert this into 10 or 20 and so forth. Okay, and depending on the size of the data that you have. Next one is the part of it. I'm talking all about under this tab, variable view. So name, type, width, decimal. So I'm just giving an overview about all these tabs what are there in the software. So in this software we have something like this variable view. Under variable view we have all this headings. So I'm just talking about this. I'll take 2 minutes on this. So width, okay, by default the width of the variable is 8. Decimal, okay, it can go up to the value of 16. Next one, so here 16 after the decimal value 3.1459. So 16 point values you can take. Label, you can specify the details of the label, the variable. You can write characteristics with spaces, and so here you can edit, you can modify whatever you want. Now this name what you give here under the name variable and this label, okay, both are almost same, but the difference is this is predefined by default. It comes once you have the data into the SPSS, and in the output, what do you want to have this variable be named as? You can type in here. You can type in here, and the same typed data or that heading or that text will appear in your output. So you have to tell us like what does this data talk about? Okay, so this is up to the researcher. Anyways, going ahead. Then values. So here again, you need to define the types of categories. Yesterday, we saw that the resource person was mentioned about the nominal type of data, that is male, female, yes, no, okay, and so on. So male, female, 1 and 2, then yes and no. Do you want to visit a place? Do you like a product? Yes, no, and so on. So all those things have to be defined here. We'll see one. We'll take up one example, and I'll just show you that. So values here, so these things, so you can insert a value and you can just mention saying that female means 2, and you say like add, and we'll just go to the next button. So this is how you need to enter into your SPSS. So this is qualitative, this is quantitative. Okay, so SPSS will not understand like who is this John, Mark, Eric, and so on, unless you tell us the gender of this individual in terms of code. So you have to code your questionnaire in such a way that you know who is what type of gender does this respondent belong to, and ultimately SPSS will take this in the form of 1 and 2, and this 1 and 2 have to be defined under the value part. So under the values here. So here if you just define under value saying that 1, if I say like 1, I'll say that this means male, and I say add. If I say 2 and if I say female, okay, if I add, so this is how I have defined. So whenever in my output, okay, so this is how it is going to be defined. So 1 means male, 2 means female. So this is how it will come across. Okay, so anyways, I'll just take this off. Okay, all right. So then, this is just one small practice exercise. We can just do it at, we'll take the practice exercise itself. Okay, so missing values is something that, okay, in the output, in the missing values also would be there. Okay, so that also we'll just see if at all there are some missing values which is there into the data. Okay, alignment can be done left, right, center based on your requirement. Measure, this is one very important aspect. As I just told you that once you fetch in the data into the SPSS software, you could see this nominal, ordinal, and the type of scale that we have. Okay, so whether it is belong to nominal or ordinal, by default it will try to understand, or else least case, you as a researcher, you know that what is the data type that it falls under, and you could manually, you can just select this. So if it is interval or ratio, it will fall under this scale, or else if it is nominal, it will select nominal. If it is ordinal, it will select, by default it will select as ordinal. So these are the symbols, okay, important to understand as a researcher. Okay, so scale. So this has been described yesterday. I'll just skip this part, nominal, interval, and so on. Okay, this is the output view. Once you have the data, okay, been punched in. Okay, so this is the data that talks about, that is income category, okay, of individuals, and the type of count that is. So how many people under age 25, under $25, the income category 25 to 49. So this is a bar graph. This is a data view out viewer. Okay, this is the same thing. So once we have the output, this is something like, okay, we'll be seeing this today now. Okay, once we run through frequencies and so on. So this is a table that you get frequency, percentage, valid percentage, cumulative frequency, and so on. Okay, now this is what I was talking about. In your data, if at all there is some missing data, so this is the total amount of data. So totally there are 105 data set or data point values that have been fetched into the SPSS. And if you are in your Excel sheet or a spreadsheet or in the SPSS, if at all there is some data missing out of those 105, it will show saying that there is a missing data. It will not show exactly where it is missing, but you will have to take the help of conditional formatting in Excel sheet, and there you can identify like which is your missing data, and go to the respondent, again go back to the questionnaire that you have collected the data, punch in the data, and again rerun the test until you get this missing value. Because again, missing value is something like, you are saying that we have done for 110 respondents, but your data is available for 100 because there are 10 respondents which are missing. So again, the answers are misleading. Okay, so we'll just run through this. Okay, I'll just move ahead. I'll just go to the second last slide. This is normality. We can take this at the end if at all we have some time. I'll directly go to the descriptive statistics. Just give me 1 minute. Okay, this is where we have, okay, descriptive statistics. So these are the steps, descriptive and so on. This is how we follow. I'll just show you one by one. I'll take a small demo. This is frequencies and pie charts and so on. Okay. All right. So I'll just close this. Okay. All right. So I'll just go to this exercise sheet. First, let me open this SPSS workbook, the PDF file. Let me see if at all I can share this. Some of the respondents were saying that you are not getting this. I'll just check if at all it can be shared directly here. No, I'm unable to. Anyways. Okay. Okay. So,
Ajay sir will post it from our side. In the
okay.
group.
All right. So I have shared this PDF copy with everyone. Is the PDF visible to everyone? This SPSS exercise, can you just mention yes or no on the chat box. Yes. All right. All right. So the first one, as we can see, data analysis through SPSS. I'll just zoom this for those who are finding difficulty. Okay. This is a self exercise. You all can just read through this. Okay. These are the precondition. You all can just read. You can just go through this. Okay. Preparation of data files. Naming variable. How should the variable be named as? So this is a very simple understanding, plain English. You all can just go through this. I'll directly jump to the exercises that we have. So label variables, label value variables, labels, missing values, and measurement level. Okay, nominal, ordinal, and scale, whether it is interval or ratio. Okay, so let me go to the first one. Okay, I have given this data set in this Excel sheet, as well as I have given a pre-filled SPSS typed data. If you really are interested to do it on yourself, you can take this PDF, you can go into the Excel sheet, you can load that, or you can import that file into SPSS. Okay, this is what. So I have already given you the SPSS file in which the data is preloaded, the same pre-data. Okay, the same data has been preloaded. Now let us try to understand. Here we have marks obtained by a student in 2 subjects. Okay, marks obtained by a set of students in 2 subjects is given below. This is first file, that is exercise 1.sav. By default, whatever files that you save through SPSS will have an extension called as .sav. Now we just take 1 minute and just try to understand like what is this data all about, or else I'll be simply running the test and then you being a spectator maybe, okay, you may not get the pace of it. So I want you all to first understand what is the data all about. So take a minute and just try to understand. So here it is like, okay, we are talking about students. So RN stand for, let us say, like roll number, okay, or whatever you would want to name. So totally there is 15 students, okay, data set of 15 students. Okay, maybe in the Excel, in the file that I have given, maybe there are more or less. But anyways, this is just an example. And the first roll number, okay, that student's gender is male. Subject 1 and subject 2 marks that student 1 has obtained is 23 and 55. Likewise, second student 45 and 87 and so on. So this is a very simple and plain data, and we'll just try to understand the descriptive statistics behind this on this data. Okay, is this clear? All right. So let us. I have also given steps. How do you need to follow in the SPSS? Okay, I have also given how do we need to follow the steps to be followed under the SPSS. I'll go slow. If at all there is something, you all can just let me know. Okay. I request Govinda sir just to have a tap on the text chat box, and if at all some respondents want me to stop somewhere, you could just unmute and you can stop me somewhere. Okay.
Sure, sir, no problem.
Okay. So the first one, what we can see, I'll just try to open the SPSS file that we have. This is the first one. That is, as I just told you, the first file has the extension what, that is exe.sav. So if I just double click on this, a pre-filled data already opens into your respective SPSS file. If not, you can manually, you can type it, you can go into the Excel, type it, or directly into the SPSS software also you can type it. That also is allowed. So I have done nothing now. This is the pre-sheet, as you can see. Okay, data view and variable view. Whichever view that you click on, it will be, there is a background that is orange color would be seen. This is just to understand that you are on what type of view table, view tab. So data view. So this is our data view. You could see that is RN number, that is roll number 7, 4, 11. This is not organized. Okay, so it doesn't matter. All right, so let us select the first one, roll number first one, male, 23 and 56. So let us confirm with our data that we have. So first one, gender male, 23 and 55. Is it the same data set? Yes. Okay, so first one, gender 1, male. Yeah.
Sorry to interrupt. There is one question.
Yeah.
They say if we say, in fact, in this example, like any student who is, for an instance, is absent, shall we have to mark it to 0, or we can left it over blank?
Left over blank. Okay. Okay. So see now, what did I see? This data Okay, now it depends like what data is coming. If you want, you can put this as 0. Now this is the data view. Okay, if you put, now if I put this as blank, okay, if I put this as blank, when I run the analysis, I am saying that I have got 15 students, but the data analysis will reflect, if you are talking about average, the average will reflect only for this 14, but this one will be left blank. If you want, you can put a number called as 0. If it is absent, now it is up to the faculty that you are saying that, okay, absent means you want to give as 0, 0, or else if you give as absent, then now you are changing, okay, the data here. So it is not taking, okay, why it is not taking, it is showing as because this is a data type. If you go on to the variable, okay, here we have given as data type as, that is okay, it says like subject 1, it is numeric. Okay, if I say string, okay, did you see that it was not taking? If I say, if I take if I take an alphabet that is absent, okay, it is not taking, it is taking as number as 0. But if I change this, so I need to define this data in the variable. So variable that is subject 1 type numeric, if I say that it is a string, if I just select this as string, and if I say okay, now it is string. Now if I go to subject 1, and if I say like this is absent, now it will take, okay, absent. Can you see this? AB, it is taking only up to the 2 letters, only up to 2 decimals. So again I need to define this width. If I say like 10, because the letters absent has got 7 letters, okay, so absent, ABSENT, 6 letters. Now it is taking, okay. So preferably, okay, now it is again up to the researcher what you want to take it. You want, you can take it 0, you want, you can take it blank, and so on. Okay, so yes, one of the answers also you can see here. Okay, we say that data cleaning is required. So you could delete, you could take that off. Maybe it is not fitting with your data. All right, so I'll just move ahead. I'll just go ahead. Okay, so we'll just practice this together. So we have the data correct. That is, okay, male 23, 55, and so on. So we have the data being correct. And now variable view. I'll just describe about what this variable view is all about. Now here variable view, in data we had 4 headings here. Can you see this? RN number, gender, subject 1, subject 2. This 4 will appear under your variable in vertical order. So roll number, gender, subject 1, subject 2. Now what is the type of data that is given under this heading is a description given here. So roll number, it is a numeric value. So let us see in data 1. So roll number, it is a numeric value. Gender, it is a string. So let us see that variable. Gender, it is what? It is a string. And what is the length of the string? It is, width is given as 1, decimal that is as 0. So here you want, you can define it. But by default, once you have the data here, SPSS is smart. It automatically takes all this value so that you need not again punch in all this data. Label is also by default. I have taken, you can by default, if you take any other data, once you start with the data, okay, it is okay. As I told you that label can be defined. You want, you can just type in saying that what does this label indicate in your output if you would want to have. So it indicates that is roll number. So if you want, you can just type in saying that roll number of the student. So roll number of the student. Likewise, gender. If you want, you can say like gender of the respondent. Okay. Likewise, subject 1. If you told you would want to know like maybe the subject 1 is, let us say like maths. Subject 2 is, let us say like science. Okay. So this is what you have labeled. Okay. Rather than just saying it subject 1, subject 2. So in your output, once you run analysis, this is what will be seen along with the table, along with the data. So you are free to define this because you are the one who have taken up this data and you know like what does this data talk about. So this is labeling part. Now in values, in gender, we have seen that gender there is male, female, male, female, male, female, and so on. And even here, and even in the here we have defined that M means male, F means female, but this is string data. Now, if you would want to count and if you would want to know like how many male, how many female, you need to code this. So you are free to code because this is a nominal data. You can code male as 1, you can code female as 2. If you want, you can code male as 2, you can code female as 1. At the end, it is going to count the number of males and females. It is going to count the number of 1s and 2s that you have defined. Okay, so this is very pretty simple. Okay, now here you need to define. Okay, so here what we have defined as F as female, M as male. Okay, if you want, you can denote that as 1 and 2 also. So let us say like if at all I have defined this, I'll just change this from value. Okay, I'll say that female means 1 and I say like change and I'll go to male. I'll just change this and I'll say like this is 2 and I'll just change it. It doesn't matter. Okay, because it's a nominal data. Okay, so 1 and 2. So this is what I have defined. Okay, so if I just want to know like what it is, just click on this. So this is what, so it will count the number of 1s, count the number of 2s, count the number of males and females. Okay, missing, it says like none for this gender. There is nothing missing. Columns 8 and left. So this is alignment and you can see the data. So nominal, it is nominal data. That's how I told you. Okay, this data, what we have, okay, it is a scale data. All right. All right, so let us see. Let us go ahead now. Okay, so let us see like what is given in the PDF. Okay, the workbook. So it says, are all with me? Can I just have a yes, no? Okay, yes, coding actually simplifies yes, 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 yes. I'm getting the yeses. All right. So let us go ahead with the first one. So it says once we have the data, so now keep both the things handy in front. Okay, you keep your PDF also open, the workbook open, and you keep the SPSS also open. All right. So we need to go to this. Okay, steps follow. That is, first we want to find out the mean, median, mode, and standard deviation in each subject. So subject, which are the subjects? Math and science. So I would want to know like what is the average marks scored by the student? What is the median marks scored by the students? What is the mode, okay, value for the students, that is for those subject, and the standard deviation for the subject maths and science. So I need to follow these steps. Okay, it's very easy and very simple. I'm going very slow because tomorrow, okay, I'll be going directly with the statistical tools. That time it is going to be a little bit faster. I urge everyone to practice through this handout, this workbook today until we meet up tomorrow again. So analyze. So I'll just follow the steps back again. I go to SPSS. I go to analyze. Analyze, you can see here in the menu. Okay, here we have analyze, and then there is a host of other sub menus that are given here. Okay, so we go to first analyze. What is the next step? We go to descriptive statistics. So we go to analyze, we go to descriptive statistics. So if you just hover around descriptive statistics, again a sub menu opens in which there is again a host of other tabs that you can include. So let us see, what does it say? Analyze, descriptive statistics, and then go to frequencies. Okay, so we go to analyze, we go to descriptives, and we go to frequencies. Okay, we go to frequencies. Now as we click on frequencies, there will be a window. On the left hand side there is something, on the right hand side there is something. So left hand side we talk about all the variables that are there. Okay, and what do we want to perform out of all this? What is the question here? What is the question? You want to find mean, median, mode, standard deviation on what? Of each subject. Okay, of each subject. So we are interested in subject. So these are the two subjects, subject 1 and subject 2, math and science. Okay, so this is what we are interested. So if you click on this and just click on this arrow, it will go on to the right side of the tab of the box, take science and also put that into the right hand side. So now we have whatever test that we want to perform, that will be performed only once we have this. So if you go on this and if I just click OK, you can see this is not been triggered. You can see this is not working. Okay, this OK button. Unless we have something here, then you will have this button being active. So this is inactive. You can see this is blurred, OK button. So I'll take maths. As I put math on this right hand side, can you see now this button has been okay, been generated, and this button is active to go. But let us take both the subjects, math and science. Okay. Now on the right hand side, you can see there are a host of buttons. We'll not go much in detail, but what do we want? What do we want from this? We want mean, median, mode, and standard deviation. So mean, median, mode, and standard deviation. As you click on the first one, that is statistics, another window pops up, and here you can find central tendency. And here you can find dispersion is nothing but your two descriptive statistics. On this side, we have mean, median, mode, and sum. So we want mean, median, and mode. I'll just check this box in the central tendency. And from the dispersion, I want standard deviation. You want standard deviation? If you want, you can take minimum value, maximum value. You want range, you can take variance, you can take everything. All up to you, whatever. All fine. Okay. So mean, median, mode, standard deviation, variance, minimum, maximum, range, and everything. Okay. Just click on continue. Okay. Then there are other buttons, but for time being, we'll just click only on this because this is what we wanted. Okay. Mean, median, mode, and all those things. We have just click on this. Charts, if you want, you can click on bar chart, pie chart, histograms based on whatever that you would want to have. Okay. So anyways, we'll just not click anything. We'll just click on the statistics, central tendency, and dispersion. So I cancel this. And now here there is a button called as display frequency table. If you want, you can check this, or else if you don't want, you can just unbox this. Okay. So unbox this. We'll just not create much confusions now as of now. Okay. And then click on OK. So as we click on OK, we have a result. This is the output window. This is the output viewer. This is a result window. Okay. So we had two windows now. In one window wherein you have the actual data, you have data view, variable view. And once you have performed this analysis and all this, there is analyze, descriptive, frequencies, and so on. After clicking the OK button, you come out with one more window, that is the output window. Okay. Now this output window, here you have the results. And on the left hand side, you can click, or you can just select which one do you want to have that active, so that you can copy this into your respective Word file where you want to publish a paper and something like this. So if I just click this, you can see here it has been highlighted. Okay, if I just click outside, nothing is there. If I click on this box, here this is getting clicked. So I just click on this, I can copy and I can directly go to the Word file, or I click on this here also, I can directly copy and I can save it into the Word file. Okay, now here the analysis or the inference. Can you see here valid 15, 15, missing 0 and 0? So none of the values are missing. The values are all appropriate and 15 is correct. The mean marks scored under mathematics subject. This is a math subject. Mean score, that is on an average a student has scored 50.47 marks. Likewise in science 59.73. Now SPSS will not give you the interpretation. SPSS will not give you the interpretation. Interpretation is up to us. Once you have the data, you need to understand what does mean for these two subjects. So average marks scored by math, average marks scored by science. And what is the inference from this? We say that the average marks scored by the student for the subject science is more than the average marks scored by the student in subject math. In comparison to math and science, science students score better in science with respect to maths. Again, inferences can be, we can say that students are weak in maths as compared to that of science. So there are different inferences. The way you would want to make your inferences, up to your data, what is your objective? You would want to compare these both and you say like science is better or maths is poorer, or maybe students need more handhold held exercises with respect to math because they have scored less as compared to that of science. So it depends what you want to find that out. So this is your mean, then median, mode, standard deviation. So standard deviation again, so as I just told you that lesser the better. So here we can see that standard deviation for maths is less as compared to that of science. It means the number of students those who have scored maths, okay, their variation is very close to this average 50.47. So that means most of the students are very close towards that value of 50.47. So some have got 50.2, 50.9 or 49 or 51, 52. They are very close towards that value of 50.47. But in science, the variation, the standard deviation is 20.373. It is bigger than this. That means the variation is little bit bigger. That means there are students who are either they are really good or they are really very poor in understanding. But in maths, almost most of the students are at the near, they are very near towards their average value itself, 50.47. So there are different interpretations that you could do. Okay, so this is again up to you. How do you want to interpret the values? So this is one. I'll show you another couple of exercises before you wind up. So bar diagram of gender is the first one. Okay.
There are two questions
Yes.
we can take up. One is about can we use both string and numerical variables? The
Okay,
same,
I'm just reading it. I got it. So can
yes,
we use both string and numerical variables in the same data set in SPSS, or should they be used separately? No, by default, there is only one option that you can select. As you can see here, the measure, okay, the string. So here there is by default, there is only one. Okay, in the entire data set, yes, there are multiple. Here also there is. Okay, here also there is. So here you can just define it because here you had all the values. Okay, this was taken as string because we did some tinkering along with this data. We wrote that absent and so on. So by default, it took as string. Okay, but anyways, I have changed it to scale. So there could be different types, but you cannot, for one type of data, you cannot have both. It cannot be done because you can see the drop down itself is there is showing only 3 options and drop down only has to be selected. Only one at a time. You cannot do it. Okay, next one, visual interpretation may not be done as I just told you, but frequencies, bar charts, pie graph and other things, pie chart and other things can be done. Okay. So we will share the recorded video. Okay, then can you please, any other queries? So sir, how Python program language adapt to research like SPSS? This is out of the scope of this FDBs, but yes, Python and R language can be integrated into the SPSS. That is much more advanced. Okay, analysis can be a tool can be adopted to it. In the question, if a person doesn't answer and I want to give him 0 points for not answering, then should I put it blank or should I give before 0 before exporting? Now here, based on your this thing, if you're saying that okay doesn't answer, okay, you cannot give it blank if you really want that respondent. Now maybe only for that one question, if it is doesn't answer 0, but there are other questions also which are very relevant, and if that respondent has answered, then definitely that respondent values should be there for reflecting the other questions. For example, if you see this, okay, now this is this 1 to 15, what we have, these are 15 respondents. So let us say like respondent number 7. So one answer, let us say like this answer 34 is not there, and if you put a 0, okay, but there are a host of other answers here. Now this entire column is for that one respondent. All the questions, okay, maybe you have 20 questions in our questionnaire. All this 20 questions answers will be given in this yellow box or in this yellow line, because this number 7 is that answers for all the questions for only for this respondent. If this is 0, well and fine, but there are other values which you have. There are other values, there are other respondents, there are other answers that this person has given, okay, and so on. So maybe this questions what you have in your questionnaire, okay, are valid. So here, if you want, you can put as 0, and yes, so rather than removing this entire this thing, if you want to clear and if you say like, no, I don't want to have this number 7 at all, you want to delete this, that is up to you. Okay, that respondent, but you need to have a fair checking across along all the data values that are put across in this respondent. Okay. Okay, please explain about decimal and width column. I have already done it. Decimal and width column. So this is one decimal and width. Okay, so gender, let us say like gender, or maybe this is for string. So okay, so here subject, that is numeric subject 1. Numeric, I have got 2 values. That is, you can take values up to 99 or 200. If I take 100, okay, it is not going to take because the width is restricted to only 2. Okay, so I need 3 here. Likewise, decimals, if at all you have some specific value, let us say like you are measuring temperature. Okay, so which is, let us say like 33.49. Okay, so decimal values will not be included. And now, for example, if I take this subject 1, let us assume that this is subject 1 and this is you are talking not subject 1, but let us say like this is the Celsius. So let us say like this 33.45. Okay, you can see it is not taking, it is just taking 33. Why? 0.45 is not taking. Why? Because your decimal that you have set is 0. Now, if I set the decimal as 2, it will take up to 2 decimals. Okay. Let us say this one. Sorry. So variable 11 is 8 and 2. So variable 11, that is say like one more variable that you have. So here it will take your 33.46. Can you see this? Now it is not taking, because now it is not taking only the numeric value, it is taking even the decimals as well. So here you just need to check, okay, in the decimal value. Okay. Explain standard deviation interpretation. I've already done it, but again, let me go through the standard deviation. So standard deviation 19.56 and 20.33. So standard deviation, now this depends on the context on what. Now when you're saying that marks scored, okay, standard deviation with respect to the student's understanding. Okay, generally the thumb rule is lesser the better. Okay, so when you say this example, or let us say like an example wherein you are talking about wage, okay, that is salaries given to the employees. So you are comparing two factories. Okay, let us say like in factory A, the standard deviation for wages is 2 standard deviation, and in factory B, the standard deviation is 5. So here the variation is less, here the variation is 5. So variation in terms of what? Wages. So generally we say that there should not be much discrepancies with respect to the salaries that are being paid to the employees. So standard deviation of 5 indicates that there is a big variation. There is a lot of discrepancies in that specific organization. Some are paid very high, some are paid very low, because the standard deviation is 5. Standard deviation 2 indicates that there is not much variation in the salaries. That means most of the employees are being paid with plus or minus with very close to the average values. So this is how you have to understand from the question part also. Okay, in this existing example, that is with respect to students getting marks. Okay, and if at all there is a remedy class that has to be given, I would say that remedy class has to be given to, okay, mathematics first, because the average value is 50 and the standard deviation is not varying much. That means I do not have to focus much on every student, because all the students are nearing towards the standard value, that is the average value, because standard deviation is low. If the standard variation is very high in science, if at all I have to take a remedy class for science, the standard deviation is high. That means there are some students who are very weak, there are some students who are really good. So I need to focus on those very less students rather than on average. But I would be more comfortable saying that all the students come to the maths class, I'll re-explain, I'll take a remedy class. But when I go to science, I need to identify who is that which is having a very low understanding. I need to identify. Okay, so interpretation should be in that way. So you have to understand like what type of questions that you are asking for that respective questions. What is the interpretation for median? Okay, so just browse through, because these are some basics. Okay, mean, median, mode. Okay, so here for example, if at all I say like median is 52 and 56, median generally talks about the middle pack. Okay, it is not affected by the extreme values, it is not affected as an outliers. So median talks about, okay, the middle pack on an average. Okay, so even the size of the shoe size that I said, if at all some shoemaker or the owner wants to, okay, put his own business, he will say that which is that middle pack. So middle pack, that is a median. So people would prefer size 7, 8 and 9. I would not prefer stocking or putting that into my inventory of 4, 5 and even extreme, that is 12 and 13. So middle pack, so 4, 5, 6 or maybe 6th or 7th is a median. So median gives me an answer about that. So depends upon what type of studies that you are doing it. Likewise, the number of average amount of income that a household would earn in order to buy a house. So what is that middle income group of people that as a banker I would want to, okay, know? So on an average, let us say the middle pack of people earning between 40,000 and 60,000 is the ideal version, or is the ideal pack wherein I would want to root out my plans as an LIC or maybe HDFC or maybe other banks and so on. Okay, all right. So I'll just move ahead. So y'all can just practice this. This is the same part. If you would want to have a bar diagram, go to analyze descriptive statistics, frequency and charts. I'll just take another 2 more minutes. So we go to analyze. You can just follow this, analyze, descriptive. Okay. Then it goes to, okay, descriptives. Sorry, it goes to frequency and then charts. Analyze, descriptive, frequency, and go to charts. So under charts, you have bar, pie, and histogram. So let us go for bar charts, and let us say like here you have again two options. You want frequencies to be plotted or you want frequency percentage to be plotted. Depends. Again, you can just put it across. You want for both the subjects or only one subject. Let us go for only one, that is science. Okay. And let us go for OK. And now you can see the data here. So this is the bar chart for this frequency count. Okay, you can see this is the bar chart. Okay, next one, if you want to obtain the total marks is not there in your this thing, so you need to create one more variable. You need to follow the steps, transform, compute variable. Okay, and just follow the steps. It's very simple. It's pretty simple. And you would want to have the total marks. You have the subject 1 and subject 2. You want the total marks. Okay, also to be displayed as part of this. So just follow this. It is very simple. Okay, go to transform. Go to transform and then compute variable. Go to transform, compute variable. Here you have target variable. Under target variable, now you can put, okay, as total. So total, I'll just say like total. Okay, numeric expression as subject 1. I'll just say like this is subject 1. Okay, plus subject 2. So we are identifying, we are defined one more new variable. So now if I press OK, now you'll see that there will be a change into the data view. Okay, you can see here. Okay, so we have one more variable called as total. Okay, you could see this total. Okay, you can see this total is already been calculated. And then under your variable view also, you can see this is total here. Okay, total has been added. So just follow this. This is a very easy stepwise reckoner. You can just go through this. You can obtain the mean scores, descriptive statistics, frequency statistics, and so on. Histogram of total, graph, chart builder. You can just go through this also. You want, you can go to histogram or histogram, simple histogram into the box. On the x-axis, you can just follow this. All right. Likewise, categorical data analysis. So again, this is under categories, different types of families, joint family, nuclear family. You can just follow this. It's very easy, very simple. Please try it out. Try this out. It should be an easy go. Tomorrow, what we can do is, I'll take a real data, a real questionnaire that I have done recently on one of the research papers, and I'll just show you the descriptive statistics in 5 minutes, and then we'll move on to the next steps. Then we'll move on to the next part. So just go to this PDF thoroughly. There are many other tools that we have added. Okay, it is an add-on. It will be helpful for you. Okay, it is way beyond the scope of this FDP. You can always refer to this and use this as an resource in future. Govindra sir, over to you. If at all there is something, or else we can wind up.
Yes, sir.
So up to you. If you would want me to wind up, we can wind up, or some queries, some questions you would want the participants to take over, they can.
Participants, if you have any more questions, we can take one or two here and there. Otherwise, we can close the session. I'm just enabling the chat. Okay, go ahead.
Good evening, sir.
Yeah.
I have a follow-up question for the question you answered already.
Yeah.
We were talking about marking when the questioner somebody is answering not willing to answer. If it is one person, okay, whatever you said is fine. But if that becomes a pattern, if one question, suppose it is a religion or a caste or income or something, and they doesn't want to answer about it, then how do we go about it?
Correct. Now, see, based on your research objective, if your research objective is incomplete without answering that question about religion, then it's a big. Then you should be more concerned about it. So you have to, you can edit, you can delete that respondent. If that question is just only for describing if for something, and your main hypothesis question talks about some other parameters, it's again quite up to you. So
yes, sir, that
yes.
sorry. In case if that question is the major thing, for example, it talks about
Yes.
the sentiment of the people, or it
Yes.
talks about the emotions of the people, then it has to be considered. So in that
Yes.
case, how do we predict that here?
See, you need to have the data, right? You need to have the
Yeah.
data. If you feel as a part of a research, and if you're doing sentiment analysis, then definitely you cannot take that respondent. You will have to skip. You will have to delete that respondent and make up for another respondent in that place, or based on the sample size. If there is enough amount of samples, then you can go ahead with the sample. If that is sentiment analysis, important question, then definitely you should have that answers. You cannot go ahead because again the answers will be biased and your response also will take a different shape. You will encounter in different inferential results out of your research work. So I think then if it's an important question, you have to omit that part.
Excuse me, sir. For
Sir,
further
one more thing.
understanding.
Sorry, one more thing. When you said we were working in the SPSS tabs similarly, side by side, but we couldn't get that output window over here, like how it appeared for you. So how do we get that?
That's what I mean. Once you click on analyze descriptive frequencies, you click on statistics, and once you click on OK, immediately a window one more opens. So that is the output window by default.
Yeah, that didn't happen. Is it because of the trial mode we are using, or?
I don't know. Now that is a technical part. It can be.
Okay.
It
Yeah,
works on even trial.
Sir,
That's not a problem.
excuse me, sir. How we put continuous variable in SPSS, please?
So can you give me an example?
Continuous variable such like height of the student, marks of the student. How we put the continuous variable in SPSS, sir?
Correct. I'll just share the screen once again.
Sir, for example,
Yes, I got it. I got it. So see, directly there is this decimal view, no? I mean, your numeric and decimal. So there you just need to enter the values. I mean, you need to give the descriptive for it, and directly you can punch the value into the SPSS. As I just told you, by default, the decimal value is 0 for continuous. Okay, so you cannot punch in directly, but for decimal, you have to give the figures. I'll just share with you once again. I'll just open the window.
yes, sir.
Okay, is the this thing SPSS window visible to you?
Yes, sir. Yes.
Okay. Now here, this is what I was talking about. This decimal, this one. So this is by default, it is by 0. So it will not take continuous values. So here you just need to increase. You can take up to 1 decimal, 2 decimal, 3, 5. Okay. Once you set this, I mean here to the new variable here. Once you set this, then you can punch in your data here under the data variable view. You can go with the decimal values. So here we have, you can see the total one is giving under the decimal. So these are your continuous values, decimal. So total variable.
No, sir. I am want to answer from your side. For
Yes.
example, marks of the student in a range 0 to 10, 10 to 20, 20 to 30, 30 to 40. Okay, sir.
Yes.
Then how
Yes.
we put such type of variable in SPSS?
See, in SPSS you cannot put this, but in the output you can generate that. In the output you can generate. In SPSS it will be in a single column. The values have to be punched in the single column itself. You cannot have
Yes.
0 to 5 and all the things. In Excel you can do that, but in SPSS you can't.
So
Okay,
sir
sir.
is trying to refer class interval 0 to 10, 10 to
Yes, I got
20.
it. I got it. In SPSS, it's not possible. In the output variable, in the output this thing view of SPSS is possible, or else that class intervals you can take it into the Excel. In Excel we can do that, but in SPSS you don't have that provision.
Excuse me, sir.
Yeah.
Before this question, there was another question asked by a ma'am saying that there are certain confidential informations in terms of collecting the data, for example, caste and other things. She said no. She asked this query.
Yeah.
So what I
Sentiment.
was thinking is before we give any survey or anything to the respondent, we send the consent form to them.
Yes.
Unless and until they are okay with the consent form, only they go ahead.
Correct. Absolutely.
Is
This is another one more way. A researcher should always be well aware about the kind of questions and the area of study that you would really want to do. Thank you for helping me with this and giving this answer. So this answer will be helpful to the previous respondent. So as a consent form, this is always an obligation. Unless and that consent form is not signed, then again that also is another one more parameter wherein you can filter out saying that okay, these are the consent forms and based on which the respondent has agreed, and accordingly the responses are been captured. If not, then maybe the consent form can be a parameter, can be used as a tool, saying that, I mean, so based on which the respondent has answered or has willingly not answered or something like that. Yes, thank you so much.
Thank you, sir, for that.
Thank you.
I think we can
Yes.
close the session, sir.
Okay.
We will again come back tomorrow. Ajay sir is going to again be with us for the tomorrow session as well. And thank you for whatever you contributed today. I hope it is very much useful for all the participants. And whatever questions you are able to answer, I think most of them were very much happy with that. And we had a great session. And thank you very much, sir, on behalf of Indian Researchers.com.
Thank you so much. Thank you so much.